Okay, welcome back. Mm, Okay, we did this example and we found the correct answer. So we can continue. I will also send you the explanation of that Indian lady that I showed you in the class before. So sorry, let me to check my voice is okay. So you can also check this video, the lecture notes, and two different kind of explanations as well. But here I advise you to not to check other resources, because in some resources there are non-preemptive shortest job first example. Sorry, preemptive shortest job first example. So in this case, you will do in different way. For preemptive version of algorithm, I will show you the round robin. So do not consider the other ones. Okay, so, or if you want to just check other resources, please ask to me to direct you, because you may learn the wrong thing, or the thing that I will not make you responsible for. So please ask to me before. Okay. So the next thing is round robin algorithm. Next week in the classroom, when we attend, all of us are in the classroom next week, I will make you to solve one question related to first come first served, shortest job first, and the third one, round robin. And also I will give you a homework related to that, so you will have enough practice for that. But for now I am skipping it because in online lectures I know that it is not so effective. I mean, just give you an example and tell you solve that. So I will continue from round robin algorithm. Just 1 second. Okay. Yes. Yes, let me to continue. Okay, I will put the slides of this. I don't know. Most probably it is on the previous year's slides. I couldn't find it, but I will send you as lecture notes. By the way, the majority of the lecture notes are taken from this resource. It is explaining in very detailed way. That's why I selected this. It is almost a kind of covering everything, almost like a book, but it is a tutorial. So it is explaining well, and it is covering all topics that we need, also more. So I am using that resource, that's why. Okay, the next one is the round robin algorithm. In WhatsApp group, they are writing just make the session online. Okay, you are not learning anything. Why? Look, friends, if you don't want to attend, do not attend. But please, also in the class, I'm not comfortable that seeing the people that always checking their phone or trying to sleep. Do not be students like that. It is not easy to tell you in the classroom, because I can't just be always the talking one. There's sometimes noise. But look, your task is not. It is something like that. Some students are like this. Think about that. You are working in a company. You are coming to your job. You are opening your computer and you are watching movie. It is not different than this. If you are a student, you have some responsibilities. One of them is, okay, you have to come to class, but it is a part of it. After you come to class, try to understand, try to figure out what's going on, try to come on time. These are your responsibilities. If you come in the middle of the lecture, okay, I don't care. You can even come or not come. It is, how can I say, I will not be upset, but the best thing is coming on time and try to listen. If you don't understand, try to ask questions. And also, not this kind of questions. When I start to explain something and spend half an hour, after that, when I say, okay, who didn't understand? Some of you are saying me, I didn't understand anything. Start from the beginning. No, it is not like that. It means that you didn't listen at all. You didn't listen anything, and just you are trying to just make me my job 2 times. Just you have to tell me, I didn't understand some points. Why you add here this one with this? Like Isaac asked me. Okay, just you understand most of the things and you don't understand a few things. So in this case, it will be meaningful. And the worst thing is, while these kind of people or these people are telling me I didn't understand anything, and as I start over, and I am seeing him that checking his phone or just continue to sleep. This is also not a good thing. Anyway, so this lecture is online because I'm sick. I will be better and I will come to lecture because I know that online lectures are not efficient so much. Okay, let me to continue. Sorry, I told so much, but it is better to be recorded. So maybe some of you need to listen it again and again. Okay. So, by the way, I'm trying to give you a friendly advice. How can I say? Really, older people was saying to me, but I didn't believe them so much. But experience is something like that. Someone is just passed that way before you and knows the things. It is not about knowledge. Experience is something like something else. So, as my experience, if you believe me, do not act like that. It is not a good thing, and at the end, it will damage to you, not anyone else. Okay. Round robin scheduling algorithm. Okay, round robin algorithm is the preemptive version of first come, first serve scheduling. And the algorithm focuses on time sharing. What was time sharing? If you remember multitasking, what did I say to you? In a limited time, a processor can execute more than one task by dividing it to small slices or small quantum of times. So let's say if we have internet browser, Microsoft Word, and let's say listening music. If these three processes, if we say each of them are processes, if three of them should be executed in parallel, it is not possible for one processor because a processor can execute only one process at a time. But on the other hand, we can just do it in very small quantums. I mean, we can execute, for example, each process in small amount of time, like 3 nanoseconds for each. So the user may think that these processes are running in parallel. Okay, so this is time sharing. Multitasking is same as time sharing. And we said as well, in this algorithm, every process gets executed in a cyclic way. So until the burst time is finished of any process, it will continue. Process 1, process 2, process 3. Again, process 1, process 2, process 3. It will continue execution. Okay, a certain time slice is defined in the system, which is called time quantum. So in the questions, time quantum should be given to us because we are not going to decide it. It will be given. It will say, for example, 2 nanoseconds. So you will apply 2 nanoseconds of time quantum. Okay, so each process present in the ready queue is assigned to the CPU for that time quantum. So all of the processes are in the ready queue, and one after the other, the processes will be executed, put back to the ready queue, other one execute, put back to the ready queue until the burst times is finished. So if the execution of the process is completed during that time, then the process will terminate. As the process will go back to the ready queue and waits for the next turn to complete the execution. Okay, I don't need a flowchart for that, but I can put the flowchart if, for example, you can actually, if this lecture will be given in 4th year, most probably I will ask you to just write a code to just run round robin or first come first serve. But in 2nd year, you are just new in programming. I mean, you saw some programming courses, but I know most of you are new in coding, so this will be a torture to you. So I'm not going to give this kind of things because it is a 2nd year course. Okay. So the advantages, it can be actually implementable in the system because it is not depending on the burst time. So this is important because I told you that in some situations, burst times cannot be estimated. I mean, think about that, if using PowerPoint, PowerPoint is a process or set of several processes. How the system estimates the burst time? I will open it. Maybe I will close it after 10 hours. Maybe I will close it immediately. Because of it is dependent to user, so the system cannot estimate it. But in this kind of situation, in multitasking or time sharing, this is implementable always because I don't care which process is executing. My task is to switch between the processes. I will execute first one, second one, third one, then first one, second one, third one. If another one arrives, I will say first, second, third, fourth. Okay, if one of them finish, I will remove it and continue execute the others. Just I am doing to execute the available processes, for example, 3 nanoseconds, each of them, and continue to the next one. Okay, and also it doesn't suffer from the problem of starvation or convoy effect because each process is executing in a specific time quantum. All the jobs get a fare. I think it should be FAIR, fare, allocation of CPU. So disadvantages, the higher the time quantum, the higher the response time in the system. So if we have higher time quantum, response time will be more. So the system will, I think, the others will wait more. And on the other hand, the lower time quantum, if we make the time quantum lower, in this case, the context switching overhead. What is context switching overhead? I mean, we will do a lot of several context switchings because think about that. If let me to just explain it in an example. So I will come back to this one. Look, the time quantum of the system is 4 units. So if you check the burst times, I can easily say that these processes can be executed in 2 turns. So in one turn, it will execute some of them. This one and this one will be finished execution, and this one. In the second turn, it will execute this one, and this one. So, but if I say time quantum is 2 units, so it should execute in 3 turns. First, it will execute, for example, this one, it will have 3. This one, then it will have 4. This one, it will have 1. This will be finished execution. Anyway, so 3 times it should be come to the beginning and execute. So what does this mean? Switching between the processes, which it means one process will be removed from the one process will be deallocated from the CPU, put back into ready queue. Then the other one will be allocated. Then it will be put back in the ready queue, and so on. So the time of this will be incremented, will be more. Not time, the number of doing this. So this will be the operation that it is doing. Removing one process and putting another one is context switching. And if it is doing it so much, it is context switching overhead. Okay, I will take the attendance in, I will do another lecture after finish this, and please do not write your names. I will take it at last lecture, okay? Please. I will not count this lecture attendance, the last one. Also, how many people are there? 20. Okay. Okay. So the switching between the processes is called context switching, and if we make the time quantum lower, it will be context switching overhead. That's why deciding because I said when time quantum is higher, the response time, when higher the time quantum, higher the response time. The lower time quantum, it will make context switching higher. It will be overhead. So the other disadvantage is deciding a perfect quantum is really a very difficult task in the system. Okay. Okay, in this example, we have 6 processes from P1 to P6. And the time quantum of the system is 4 units. So we have some arrival times. We have some burst times. So now we have to check which process is in ready queue at that moment. Because this is a preemptive algorithm, but in this case, we are not considering our thing that we are going to consider is the time quantum. So, for example, if it is 2 nanoseconds, each process should be switch and another process should come. So here, first of all, we have to check which process is arrived first. Which process is arrived first? The arrival time 0, process 1 came. Okay. So first of all, CPU will start to execute process 1. So because of I said that the time quantum is 4 units, so it will not be interrupted till it is 4 units. It will execute 4 units and continue. So let's check. When time is 0, it will take process 1 for execution 4 units, which means after executed 4 units, it will not remove from the memory. It will stay the memory and wait its turn again. So when time is 0, P1 is in ready queue. This is ready queue, okay? So P1 will be executed for 4 units here. Okay. This is the starting part of the Gantt chart. Okay, some people are not listening, they're just writing the student numbers. This is I am talking about. What is, you are wasting 2 hours, 3 hours, and for what? Anyway, even it is when you go to a cinema, even it is a bad movie, you are watching it. So you are attending to lecture and you are not listening. Okay. So when time is 4, when time is 4, I mean, this one is executed 4 units. When time is 4, can you tell me which processes are in ready queue?
Process 2, process 3, process 4, and process 5.
Yes, exactly. So they are in ready queue. I can take them in order. Okay, 2, 3, 4, 5, you said. So let's check process 2, process 3, process 4, and process 5. This is showing the order of execution. Okay, the arrival, what did I say to you? It is the preemptive version of first come, first served. So the first come will be served first. So look, process 2 will be executed next, then process 3 and process 4 like that. What about this one? I put process 1 after process 5 because process 1 is executed for nanoseconds. Let me to write, draw at least. Okay, this one was executed 4 nanoseconds. So 5 minus 4 is 1. And this is actually when process 1 is executed and finish execution, okay, process 1 found all these processes in the ready queue. So it is something like you were just on the first line, cashier, you are for example, the lady in front of the desk asks you about your ID card, and you said, okay, or how can I say another example? This is not the correct example. Let's say you were playing an Atari game, and it gives you 2 minutes for play that game. After 2 minutes, it is finished, and you went out to or you go to the place to take some coins, and when you come back, you found that there are 4 other people are waiting in front of that Atari. So you are the 5th now. Okay, you have to wait your turn. So when the process 1 is executed 4 nanoseconds, and after it's arrived in time 4, when it is arrived in time 4, it found 4 other processes. So if we are making an order, P2 will be executed, then P3, then P4, then P5, and then P1 will be executed. So we should put P1 after P5. Did you understand that?
Yes, sir.
Okay. So if you got it in first time, it is perfect. So, okay. Let me to continue. So, I told you it is preemptive version of first come first serve. Then they will execute in this order, but we have to consider the processes that arriving to ready queue or just removing from the CPU and put back in the ready queue again. So the next one is I am going to execute by the way, I forgot P2 is where? Here. Okay, P2 will be executed after that. 4 nanoseconds. So first P1 is executed, then P2 will be executed, as I told you. So time is 8 now. When time is 8, look, the P6 is also arrived. So while P2 is executing, P6 is arrived to the Q as well. So after this one, I have to put P6, and after at time 8, when P2 finished its execution, I will put P2. So it will execute P3, okay? And then now after that, when all the processes are arrived, it is easy. When a process is not finished, for example, when a process execution is not finished, so let's say this one is executed 3 nanoseconds, so it will finish execution. Then this one will execute 1 nanosecond, it will finish execution. Then P5 will finish, sorry. Okay, they will finish. Will execute 5 nanoseconds. So, sorry, 4 nanoseconds. 1 nanosecond will left. I will put it at the end of the queue. Okay, I will always do like that. So I will show you an example, I mean, in video, so it will be better understanding, because I'm limited to draw something here. But as you see, after that, it will execute P4, 1 nanoseconds. Then it will execute P5, 4 nanoseconds. P5 will be put at the end of the queue as 1 nanosecond. Look here, as you see. And it will continue like that. This one will finish all of them, so you don't need to do anything else. And at the end, let me to check if it is this last one. At the end, you will find this Gantt chart. As you see, it is executing one after the other, and this is doing by a specific time quantum. It is called time sharing or multitasking scheduling. Okay, I will show you a video related to that, but let me to also, the thing is always same. Let's do this by just showing, and I will continue. Why it will not be smaller? Oh. Sorry, I will make it bigger. Or no, this is the best view. Okay, I will disconnect, finish the lecture, and I will connect to my last lecture, okay? So in last lecture, you can just write your student numbers. I will just immediately open the next lecture.